Hello everyone, thank you for welcoming me in Linz. My name is Fiona and I'm an architect and neuroscientist. And my main research hubs are the Holon Architectural Laboratory at the University of Innsbruck, the Ministry of Mind and Matter at the Bartlett School of Architecture, and Spears Lab at UCL, which I will talk about a little bit later in my talk. And also my design practice graph takes knowledge that I work on in neuroscience and translates it into building design. So, In 2013, I started a transdisciplinary PhD at University College London, at the Bartlett School of Architecture and at the Institute for Behavioral Neuroscience to explore the internal construction and experience of external space and their reciprocal relationship in order to then embed the resulting knowledge into the realm of architectural design and develop a novel workspace shared with neuroscience. So what is my focus that I'm working on? In an ever more globally networked world, humans are developing new modes of cognition, new subject and object relations, and evolved spatio-temporal realities and relations. As part of the socio-cultural environment, architecture operates within these evolving tangible and intangible local and global networks, and is changing in interdependency with the evolution of minds and society. My architectural design research uses knowledge drawn from neuroscience of how the brain constructs and represents space to aim to respond to said changes. I use neural activity patterns and neurophysiology strictly as guidance parameters in my design research, not, however, in a reductionist and causal way. While it might be fairly new to use such knowledge explicitly, designers have long followed the workings of the mind as design guidance intuitively. The neuroscientist Antonio Damasio, referring to similarities between multicellular organisms and human societies, sums it up when he says, and I quote, "The resemblances are staggering." To understand the material and immaterial processes involved in the neural construction of space, I explore architecture all the way from interiors to urban environments and users as dynamic processes in both virtual and actual settings. At Spears Lab, we specifically investigate urban navigation and neural representations of space. This work is one example of how my research relates directly to investigations of cities. Minds and bodies are part of constructed assemblages, such as cities, merging objects with subjectivities and operating within vast networks of institutions, media, and technologies. The mind and body are no longer given or even stable reference, but immanently and intimately designed. As architects, we design external environments, buildings, spaces, cities, and based on their interconnection, subjects. I believe we should approach design as neither subjectivist nor objectivist, but relational. This is essentially an organism environment model, which is reflexive in that whatever one experiences is derived from the what and how of the external or environmental context in relation to experience. Neuroscientifically, the relational tandem of perceptive sensibility and environment indeed underlies intelligent action. Damasio writes that perceptive impulses are triggered in response to stimuli, which elicit feelings, which then enable higher order thought and thus reasoning. Conception, how we design, is thus only possible in relation to perception. How we perceive current environments is therefore intimately related to how we design future environments. To understand the relation, To understand the relation of the brain to our current environment, neuroscience is interested in a range of questions, some of which Spears Lab addresses. We are interested in the neural network's underlying spatial abilities and how the various constituents work in synchrony when people wayfind, strategize movement, estimate distances and directions, and feel while they are navigating. One experiment at the lab is navigating Soho. For the past 5 years, Soho in London has served as a testing ground, and the lab has run experiments both in virtual reality and in the real world. Here on this slide, you see preliminary results of the correlation of hippocampal activity and street network connectivity. And at first what we're finding out is that it appears that connectivity of street networks is directly related to how the hippocampus responds to its current environment. This experiment is ongoing, and if you're interested, my collaborator Panos Mavros, who's sitting right there, and I will be running a workshop on Saturday where we'll take you on a behind-the-scenes tour of the experimental paradigm and what we're finding out about how the brain indeed constructs space. Thank you.
So good morning from my side. My name is Markus Fiege. I'm happy and proud to be here with you today. And so some words from my side to my person today. As I stated, Markus Fiege, my name, born in 1978 in the green and rural heart of Germany, moved to Stuttgart in early childhood. It's the southern part, and living there since 25 years now. And there, after graduation on the school, I started my studies at the Cooperative State University together with a smart company. It was an interesting time, and as since 37 years, my hobbies are still the same all the time, building models, solving technical problems, and using mechanical two-wheelers. It was clear that I have to study engineering, so that's the reason why I finished in 2002 my studies in mechanical design. And after that, and since that time, I'm working for Mercedes-Benz in the R&D, Research and Development Department in Sindelfingen. It's the biggest research facility in the company, and that's, as I stated, since 2002. At that time, or in the beginning, I was there working as a project leader on different exterior lighting projects, headlamps, tail lamps, technical issues, technical project leader with focus on lighting simulation, mechanical design, and Electronica issues, the classical technical program. But at that time, interesting thing was the style change we had in the whole automotive industry at the last decade in exterior lighting based on LED technology and such developments. So we had interesting tasks at that time, the last years, bring together the tensions between styling and mechanical design. And it was interesting and a complete new view for a technical guy. So I had a lot of interesting experience then. After that, 2 years of testing experience was important impressions regarding safety, sustainability, and reliability. I think it's not so important for today. But I think the most important step, and for me in my career up to today, and even the reason why I'm here today, is that since 2014 I'm responsible for the lighting innovations in the company. That means all lighting issues on the Mercedes-Benz cars are discussed in my team. So we think about mid and long term, the next 5 to 10 years. And that means, for example, how can we use the light which is brought by the headlamp, not longer only for the driver, but for the people around, for the pedestrians, the walker who goes by, which are blinded today, and so on. So what is the idea behind developing lighting further? Then the same for the interior. We have a lot of interior lighting in the car. It's blue and yellow and red, and it's a show. Yeah? But what we're thinking about is how can we use it for well-being, comfort? How can we bring together the passenger with the technic? And this year we had, or my team had the unique opportunity to bring some of our ideas on the lighting issues in one of our show cars. You can see it outside. It's the FO15. And there we unite some of the ideas in interior lighting. How can we develop further? How can we change lighting at the car or in the car when autonomous driving will be established? And the same is for the outside view. How can we use the light, or how do we have to use light for the communication with the pedestrians, with the walkers in the street, with the surrounding, in case of autonomous driving, for example. So that's the reason why I'm here today, bringing some of my ideas, but more important, discuss some of your ideas regarding the future city, autonomous driving, machines, and I'm really looking forward to it. And thank you for listening and hopefully having a good time together. Thanks.
You hear me? Okay. I'm Umut Gökçen Yılmaz from Turkey, Istanbul. I am an entrepreneur nowadays, so-called. In fact, I'm doing my own business for more than 12 years. The company I own now is Nomad, is a fintech solution company, but it is the 5th one that I have in a row. So it is called serial entrepreneur, as if I understand correct from today's this. I have been a licensed chess player and pretty much successful at my age 12. And in the university first grade, I have patented my first hardware, which is basically designed to measure renewable energy resources like sun and wind and the humidity around you. So it was a very early stage. I successfully sold it to someone to earn my very first money. And in fact, it is very hard to describe yourself. So I asked a friend of mine that how you describe me if you look to the jobs that I did in the past. So they described me like that. You are a technical guy who also understands business and can manage people. This means in a very short session that I can make money off technology. As they all mean this one. And my company now around 55 engineers located in Istanbul, one in Amsterdam and one branch in London. We are working on connected devices, mobile applications, and many other technology stuff which are buzzwords today, and big data, Internet of Things, and handling many execution of those technologies in an applicable way. And this presentation is also designed by obeying the rules that I given in the form, so it is not as beautiful as the previous ones. I'm sorry for that. I always obey the rules. And to be honest, and I really describe myself again to what I did, I dropped 2 master degrees because I couldn't succeed or survive in an academical environment. I was much more a practical guy to do things in hand, to do engineering. I like playing with any programmable things that I like to. I have 5 companies, but 4 almost fails, let's say, not very successful ones. They are earning money, but I mean, Google did not buy them yet. I have an art collection. Well, this is, again, this presentation was written on the sentence that describe yourself in profession, art, and science manner. So I tried to look my past at what is my relation with art, and I only found this. I get art pieces from artists in exchange of technology. I make their mobile applications, websites, or organize things, and instead of money, I get them art. So yes, this is not a very good thing, but I do it, yes. And so I'm the guy who you hate in high school because he almost have answer to everything. You don't? Okay, great. At least one guy doesn't hate. The others agree, as I see from the silence. Okay, this means pretty much much more educated easily. That people talk to intellectual property, and I am to be smart, known to me, but not very well educated in these early ages, because at that time in Turkey, people are not very used to the intellectual people. I mean, we don't very get prepared to see some people smart, so you need to be step by step educated properly. This is how I became a business owner very early in university. I'm a lifetime nerd, okay, and the patented hardware I did in 2002 was not even working. So this is the honest description of me. And again, next, why I'm here. And I believe when I look to my credits, and I have an IoT Academy named an organization which they on cooperation with Kadir Has University in Turkey. I'm doing mentorship in it. I'm trying to talk about technology culture. And as Turkey is a developing country, as we see our European partners and European business around, we accept this to talk about technology and how it is supposed to be used for smart cities, for smart people around. I know how we see the smartphones affect our community, and the technology affects, it changed the way we think, it changed the way we interact each other. So first of all, we try to let it to be understood by the people. And second is, it's probably a game we designed in Almere. It's an Internet of Things game in urban areas. It's called Urban Play. Basically, it's working like that. You go to you're at the quarter mark, you're looking to a fountain. It creates shapes and colors by using the fountain pumps and the lights there. So you try to remember the shapes, and it is basically a memory game. So it collects people around it. You take out your smartphones, play the game, earn voucher points, and then go and spend these vouchers around the area. So it is a basic execution of a simple idea that you go and in a part of city that if you want to play a game, and if it could be a useful output for you, it should be looking like this. It was a demonstration. It happened 2 years ago with Almere Smart Society, but it worked. And this is pretty much one of the reasons that I'm here, I suppose. And also with my company, Nomad, we are creating smartwatch and mobile applications, wearable devices, and any other shiny toys nowadays you can find around you. And we have more than 200 mobile applications, but I chose those 4 of them. And one is long live mothers, maybe. And it is collecting heart rate and collecting data from step motions of application and uses to understand the condition of the mother. And also very personal insurance application using the same data to offer you a better price. Smart shopping is actually, those are all executions that you like to see around how the technology to be used, as believe. And finally, what I am to do here, I'm imagining a city knows you, understands you, talks to you, technological mind, and I got the tools for it, and basically know how to execute it. So I think this is my opportunity and my duty in the team. As I did in my life, I'm going to try and fail, well, I hope we do not, sorry, and cooperate, and finally the successful solution going to survive. Thank you.
Good morning, everyone. I'm Matthias, and I'm an architect with a certain passion for creating technologies. And to introduce myself further, I'll show you 2 of my projects. First of all, I want to talk about local warming, a project that I did while I was still working with the Sensible City Lab at MIT. And we looked at the correlation between a building's energy use for heating and a building's occupancy. And to no big surprise, we found out that there is no real correlation. So we dug a little deeper into heating systems and basically found out that what has to happen, what has to be done by a heating system is a certain transfer of energy from an energy source to people. So what we did was, what you see here mounted above the main entrance of MIT, we built an infrared energy beam that uses computer vision to find people and provide warmth to them. In a second version of this, we built a bigger battery of emitters that only rotated around one axis to, again, provide warmth to people. And this way, you no longer have to heat buildings, but you can heat people directly. This project, by the way, was what you see here is how it was shown at the Venice Biennale last year. This is the second project I'm going to show you. It's my current project. I'm thinking about strategies for the automation of architectural production. And I believe that we are heading towards a future in which manual labor will no longer be a necessary part in the production of the artifacts that we have to use for our lives. And the same goes for buildings and our cities. And so what you see here is the product of a model process that I did for my master's thesis in architecture that basically takes over everything from design to the finished architecture. It starts with a human input. A designer or architect envisions the shapes and spaces and draws them. And then an algorithm starts to analyze these shapes and spaces and rebuilds them by using automatically generated modules. But these modules are not, as you are used to architectural modules, they're not the same in shape. Every single one of them is unique physically, but they do follow, they do carry the same DNA of rules, much like an object in software development, for example. And they obey these rules and they follow these rules and they are created through these rules. And these rules also define the interfaces along their edges at which they connect to the neighboring modules. And this way it becomes possible to, for example, remove single modules from the whole or even bigger subsets of modules and replace them by different subsets of modules that might look very different, but that that are compatible with the combined interface they are having with the rest of the architecture. This way, architecture becomes gets a very new degree of flexibility, and I like to imagine how cities could change if the buildings that they are composed of would exhibit this degree of flexibility. And now, more than anything, I'm looking forward to meeting as many of you as possible and to all the discussions that we're going to have and talks that we're going to have in the course of the next couple of days. So thank you.